A very good morning all of you. Welcome to lecture number 30. In the last lecture we have seen a comparator circuit, how to construct the comparator circuits and compare the 4 bits, 8 bits and so on. In today's lecture we are going to see multiplexers and demultiplexers. These two topics are interrelated to each other. So in the first part I will be discussing about multiplexer, then we will discuss the demultiplexer, but first few minutes we need to discuss both simultaneously. So let's start with multiplexer. So multiplexer, we call this multiplexer as data selector. We'll see how it is going to select the data. Similarly, your demultiplexer, we call it as a data distributor. Now the question is, where do we use these multiplexers and demultiplexers? As you seen in case of adders, subtractors and comparator, we have seen a real-time application where we use the arithmetic logic circuit as well as the comparator circuit. Similarly, when you consider multiplex and demultiplexer, these will be useful in digital computers or your digital devices where you need to multiplex your data as well as demultiplex your data. Let me take a simple example to understand what I mean by multiplexing data and demultiplexing data. Let's take a simple example. Suppose you are having a mobile phone. You have an iPad, and you have your desktop computer, and you have a laptop. Now all the four are connected to a circuit that is nothing but a multiplexer circuit. Please try to understand. Now you are having 4 different devices: your mobile, your iPad, desktop and laptop, and you want to play music in all the cases. You are playing music in all the cases, but you have only one speaker system. You are having only one speaker system. Now this circuit, this box is multiplexer box, and is going to have 2 control inputs. By the time you make it as a 0, you are having 2 control input. Based on the 2 control inputs, either the music which is playing in the mobile will be played in the speaker, or iPad music will be played in the speaker, or desktop or laptop music. So that means your multiplexer is selecting a data out of 4 and sending the data to the output side. So that's why your multiplexer we call it as a data selector. In this case we have a 4 possible combination. Your S0 and S1 can have 0 0 0 1 1 0 and 1 1. In this case, when you select 0 0, your mobile will be selected, or whatever the music which is playing in the mobile, that will be transferred to the speaker, and speaker will play the music. When you keep 0 1, you can choose iPad, then 1 0 will be desktop music, and you can see the 1 1 will be the laptop music. So that's how your multiplexer going to select out of many inputs. One input will be selected, that one particular input will be transferred to the output side, or transfer onto the a data bus or a travel path which is supposed to travel. Okay, so this is the simplest way to understand the data selector application of your multiplexer. This will be useful in almost all the digital systems. Now we'll try to see the demultiplexer application. So as I said, your demultiplexer acts as a data distributor. So to understand this data distributor, what you do, you take a simple example now. Now you are having a computer and you want to print some document. Okay, but you are having a different printers. We have a black and white printer, black and white printer and color printer, and you have a different company printers. like one can print A4, one can print A3 size. Okay, now the moment you give the instruction that I want to print a document with the specifications, it goes to a circuit. So the circuit is nothing but demultiplexer circuit. It is also having two control lines, or any, depending on how many output you are going to select, and depending on these control lines, your S1 and S0 are control inputs or control lines. Depending on this S1 and S0, the print job either select either black and white printer or color printer or A4 or A3. That means the same data is transferred to 4 output ports or 4 output devices. That means it's distributing the same data among 4 devices. I can print the same print, either a color print or black and white. If not, I can print A4 sheet or A3 sheet or A1 sheet. Okay, so here your demultiplexer is doing a job of distribution of data. Okay, so you can correlate both at one place. Your multiplex and demultiplexer will exist in any digital device, where you can select data out of many, and the same data will be transferred over a transfer line or a bus, and the same data will be distributed among many output devices depending on your interest. If you want to understand even more clearly your data cell and data distributor, you can simply take example of your telephone or your phone network. Okay, so if you take a phone network, your multiplexing and demultiplexing action can be easily understood with a simple telephone network or telephone conversation system. So you have a different users at left side. Present this left side, you have different users, user 1, user 2, user 3, user 4, and so on. So these all the users will be connected to a circuit called multiplexer. And you are going to have one output line. This is your output line. This output line will be connected to a demux here. That means your demultiplexer here, and you are going to have user 1, user 2, user 3, or user 4, or you can instruct. Now both the multiplex and demultiplexer will share the same control lines. So if I apply the same control lines, suppose it's, since there are 4 users, I can have 2 control lines, S0, S1, S0, S1. If I make 0, 0, my S0 is 0, S1 is 0, user 1 will be selected, and this user 1 selected data will be transferred through this data bus, and the same will be delivered to the user 1 on the other side. Similarly, if I take, so that means user 1 and user 1 will be connected. When you keep control is 0, 0, if I keep 0, 1, you are going to get U2 and U2. That means user 2 conversation will be reached to the user 2 of other side. Similarly, if I take 1, 0, your user 3 will be reached to the user. That means you are going to have connection through multiplexer. Multiplexer select the user 3. So user 3 will speak, the same information will travel through data bus and will be reached to the U3 on the other side. So this is how your multiplexer and demultiplexer play a major role in data selecting as well as data distribution. If you want to say in a simple word, you call it the mux instead of multiplexer. Your multiplexer has n inputs. You can have n inputs, but you should have only one output, and you are going to have m select lines. We will see how your select lines will be decided. This is for mux. If a demultiplexer, we call it the demux now onwards. A demultiplexer will have only one input, but you are having n outputs. You are going to have n outputs with m select lines. we'll see how this M and N will be decided. This will be demux and this will be mux. So this is a basic introduction about your multiplexer and demultiplexer. Now we will completely focus on the multiplexer part. So in order to understand the multiplexing action, first we should understand basic working of AND or NAND gate, because we are going to use AND gate for generating multiplexer circuit. If you take the AND gate, you are going to have two inputs and one output, here A and B, and your output will be A dot B. Suppose if I make B equals to 0, so whatever the input you are going to apply at A, that will not appear at the output, so you are going to get output as 0 as long as your B is 0. Similarly, if you keep B equals to 1, you are going to get output Y equals to A. That means your one of the input of the AND gate can act as a control, to allow the data or block the data. That means it will transfer the data or it will block the data. So this property we are going to use to construct the multiplexer circuits. Now we'll try to see a simplest multiplexer, 2-into-1 multiplexer. Now we'll try to see the 2-into-1 mux. So moment I say 2-into-1 mux means you are having two inputs and one output as usual. Okay, for two inputs I am going to use two AND gates. So this is my first input D0, that is data 0, and this is my second input data 1. Now I am going to take one control, second input as control. So I am going to use one NOT gate here, and the same is connected to the second AND gate also. I am taking this as a control input, or consider as 0. Now we are going to add these two to a OR gate. This is my output Y. Okay, now if you look at this circuit, if you carefully analyze, when S0 is 1, now if you carefully analyze this circuit, when S0 is 0, assume this is AND gate, this is first AND gate, this is second AND gate, and that means you are going to get 0 here and you are going to get 1 here. That means your gate 1 is activated and your gate 2 is deactivated. That means when S equals 0, whatever the D0 that going to appear at the output side. When S is 0, you are going to get output as D0. Similarly, when S equals to 1, when S0 is 1, your gate 2 will be activated this time, because it is having one input. Now when it is 1, it is going to be 1 and this is going to be 0. So this will be deactivated and this will be activated. In this case, you are going to get output. Your gate 1 will be deactivated because it is going to get the input as 1, and you are going to get Y equals to D1. Now it is very clear, this control line S0 is selecting one of the input to travel from input to the output side. So now this entire thing will be in the box. So when you want to write a 2-into-1 mux symbol, you are going to write just simply a D0 and D1, and you are going to write one control input as 0, and you are going to write output, and you are going to write 2-into-1 mux. So this 2-into-1 mux circuit is having two AND gates, one with one OR gate, and this control input going to control your data selection, whether D0 should be transferred to the output side or D1 should be transferred to the output side. So this is the simplest example for the 2-into-1 mux. Okay, now coming to your select line, how to select the select line. Suppose in this case you are having one select line for 2 data bits, or you can say 2 power 1 data bits. Similarly, when you have 2 select lines, you can have 2 power 2 data bits. That means you are going to have 4 data bits, 4 data lines. Similarly, when you have 3 select lines, you can have 2 power 3 8 data input. That means when you have 8 data bits, you want to multiplex the 8 data, then you have to use the 3 select lines. When you are having 4 data lines, you are supposed to use the 2 select lines, and so on. So this is a simplest 2 into 1 mux. Okay, now I am going to add one more input to the 2 into 1 mux. Let's see what it is. I am going to add one more enable input. I am going to add one more enable input to the 2 into 1 mux. This enable useful in enable or disable the circuit, and also cascading. Please remember this, very important. Cascading or designing higher order mux using lower order mux. Please remember this statement. I am going to add one extra input, that is enable, to the multiplexer circuit. This enable will be useful in cascading, as well as it is going to be useful when you want to design a higher order mux using the lower order. That means, let's take a simple example. Suppose you want to construct 8 into 1 mux using 4 into 1 mux. So in this case, we are going to use this enable input to construct 8 into 1 mux. So let's take modified circuit. Let's try to see modified circuit, how we are going to modify the circuit to add one more input as enable. I'm going to add one more enable here. This is going to be enable, or sometimes the people take even with a NOT gate. In that case, you are supposed to write enable bar. So for the timing, I am considering this enable. That means when enable is 1, your circuit will start working. Circuit starts working. When enable is 0, your circuit will not do any job. Circuit will not do any job or any data selection. It will not select any data selection, or if I want to say in simplest form, now I am having my 2 into 1 mux here. So I am having 2 inputs, my D0 and D1, and one select line is 0 and one enable line, and there is my output Y. If I want to write in a tabular column, my D0 will come here, D1 here, D1 here and D0 here, and you can take my select line here and you can take enable here, then you type the output. Now in this case, when enable is 0, it doesn't matter whatever the inputs, what are the select line, it's going to output as 0. That means it's not going to select anything. The moment your enable is 1, now it will take the select line. If the select line is, let's say, 0, let's take all possible combinations. Listen carefully, I am taking all possible combinations. The first one, when the enable is 0, your circuit will not enable. It's not going to produce any data selection. It's going to get output 0. The moment enable is 1 and S0 is 0. When S0 is 0, you are supposed to get the output of D0. That means your output should be the same as your D0. That means you are going to transfer this data to output. So that means 0, 1, 0, 1. Similarly, when you take S0 equals to 1, let's take once again 0, 0, 1, 0, sorry, 0, 0, 0, 1, 1, 0 and 1, 1. In this case, your enable is 1 again. That means your circuit is enabled. Now your S0 is 1, your select line is 1. That means you are going to get D1 D1 inputs to the output. So that means you're going to get output as 0 0 1 1. So if you look at here, when S0 is 0, your D0 bits are at the output side. When S0 is 0, your output is D0. When S0 is 1, your output is D1, provided your enable should be high. Okay, so this is how you can add your enable input. Now we'll try to see 4 into 1 multiplexer. Let's take 4 into 1 mux. As you said, there are 4 input bits. That means you are supposed to have at least 2 select lines. Then only you can have 2 power 2, it will be 4. So you are supposed to have at least 2 select lines. The select lines I'm assuming it as S0 and S1 this time. So that means you are going to have a circuit something like this. You are going to have your D0 to D3 here, D1, D2. Then you are going to have 2 select lines, your S1 and S0 and 1 enable input. Okay, then you are going to get output here Y. So this is my 4 into 1 multiplexer structure. Now I am going to show you the circuit, how your S0 and S1 are connected to your D0, D1, D2, D3 as well as your enable. Okay. So what you do is, since you are having 4 data bits, you are supposed to use total 4 AND gates. So if you want to construct a circuit for 4 into 1 mux, so you are supposed to have 4 data bits. That means you are supposed to use 4 AND gates. So 4 AND gates will be connected with the respective data. This will be D0 and your D1 and your D2 and your D3. Now your data bits are connected to the respective AND gates. Now I am going to choose my S1 and S0. So please, I am just drawing a line. Wherever I keep the bubble, that particular line is connected, otherwise no connection is established. Just for the simplicity I am drawing this way. Now nothing is connected. Please, I did not put any bubble anywhere. I am going to take my NOT gate line also here. Now for the first gate, this gate 1, let's say gate 2 and gate 3 and gate 4. For the first gate I am going to take S0 and S1 0. So that means when S1 and S0 are 0 0, this AND gate output will be 1. That means it's going to have S0 bar S1 bar times D0. And similarly, if you take the second AND gate, you are going to take S1 bar, that means this one, and S0. We are taking this time S0. Please carefully connect the connection. Now this output will be S1 bar, S0 and your D1. Similarly, if I connect for gate 3, you are supposed to take your S1 and S0 bar. So in this case my output will be S1 S0 bar D2. In the last case I am going to take S1 and S0 directly. So this is my and I'm going to take S1 here. So my output will be S1, S0, D3. So all these outputs I am going to connect with an OR gate, and this is my output. Now you can clearly see when S1, S0, if it is 0 0, you are going to get output D0, 0 1 you are going to get D1 output, 1 0 you are going to get D2, 1 1 will be D3. So when 0 0 your gate 1 will be activated. That means gate 1 will allow the data from D0 to Y, and rest all other gates will not activate because you are going to get one input 0 for the AND gate. Similarly, when D1 is 1, similarly when S1 and S0 are 0 1 you are going to get gate 2, again gate 3 will be activated. When both are 1 1 your gate 4 will be activated, your D3 data will be transferred to the output side. This is without enable. If I add enable, I am going to add enable now. So you are supposed to add one more line here. So this enable line will be connected to all the AND gates. So this time taking enable bar. So this is my enable input. Enable bar means whenever your enable is 0, your circuit will work properly. Whenever enable bar is 1, your circuit will be disabled. So when enable is 0 it will be enabled because the active low input. If you look at here, there is a bubble, there is a NOT gate here. That means whenever you give 0, this becomes 1 here, and 1 will apply to all the AND gates, then all the AND gates will be activated. Once all the AND gates are activated, based on the select lines, one of the input will be transferred to the output side. But when you keep enable bar equals to 1, this becomes 0 and all the AND gates will be deactivated, or it will block the data from input to the output side. This is how you are going to construct the 4x1 multiplexer with a enable. So in a simplest block diagram we can write it as, you are going to have 1, 2, 3 and 4 inputs, your D0 to D3 lines, and you are going to have 2 select lines, that means S0, so S1 and S0, and your enable bar. So enable bar will be E bar, and I am going to have my output Y. So this is your 4x1 mux. Similarly, we can construct 8x1 mux by simply taking 8 AND gates and 8 data bits. That's one. Suppose if you want to construct 8x1 mux, what you are supposed to? You are supposed to take 8 AND gates and 8 data bits or 8 data lines at D0 to D7, and since there is 8 data lines, 2 power 3 will be 8. That means you are supposed to have 3 select lines. Okay, that means you are going to have a circuit something like this. You are having one circuit. Your circuit will have D0 to D7 as your data lines, and you are going to have 3 select lines this time, S0, S1 and S2, and you are going to have, as usual, enable bar, and you are going to get output Y. This here 8x1 mux. Okay, this 8x1 mux. Now I am going to show the 8x1 mux construction. Now let us construct the 8x1 mux. So as I said, if I want to construct 8x1 mux, I need total 8 AND gates, 1, 2, 3, 4, 5, 6, 7, 8 AND gates, and these are my select lines, S0, S1 and S2. I have taken complement lines also for the simple circuit design, and this is my enable line. I am going to connect one by one. So let's take S1, S2, S1, S0. Let's take when all the zeros. Let's take all the zeros. In that case, your output Y should be D0. So I'm going to connect it here. So 1. So wherever I kept the bubble, that part is connected, and which is not connected, that there is no bubble. And this here For this I'm going to connect my D0 and I'm going to connect enable also. This is my enable. So this output Y will be, this output will be S2 bar, S1 bar, S0 bar into D0 into enable bar. Similarly for the second case, for the second AND gate, you are going to write S0 and S1 bar, then S2 bar, and for this I am going to connect D1 and I am going to connect enable also. So this will be S2 bar, S1 bar, S0 into D1 times enable bar. Similarly you can connect this one also. This will be S0 bar, then S1, then S2 bar, then you are going to connect D2 here, then you are going to have S2 bar, S1, S0 bar, D2 into enable bar. So I am going to connect my enable. Next I am going to connect S2 bar and S1 and S0, S0 and S1 and enable bar. For this I am going to connect D3. So this output will be S2 bar, S1, S0, D3 into enable bar. Similarly you can connect all other. Similarly you are going to connect all other AND gate, and finally you are going to connect all these things to an OR gate. And this OR gate going to produce the output. So you can remaining things you can connect it. So if you want to take the last one, where you are going to connect here S0, S1 and S2. For this I am going to connect D7 and my enable bar here. So this is how you are going to get S2, S1, S0 and D7 type enable bar. So this is how you can construct the 8x1 mux. Now I am going to show you simulation of 2x1 mux and 4x1 mux and 8x1 mux in a moment. Now we'll try to see the simulation of 2x1 multiplexer. So this is a 2x1 multiplexer and these are my data bits D0 to D1 and this is my select input. If you look at the simulation here, the moment S0 is 0, you can see there is an arrow mark, that means this data line is enabled. So if I make D0 is 1, 1 will be appeared the output side. If I make 0, 0 will be appeared. That means when S0 is 0, this D0 bit is transferred from, or the data D0 will be transferred to the output side. The moment if I make S0 is 1, my select input as 1. You can see arrow mark has changed to the I1, that means D1 bit. That means this time whatever the D1 that's supposed to transfer to the output side. If I make D1 is 1, your output also will be 1. That means your data bit D1 is transferred to the output side. Now if you do any change in the D0, it doesn't affect your output because this line is not enabled by your selecting. This is how your 2x1 multiplexer will be working. Similarly, if you look at the 4x1 multiplexer here, where you are going to have two select lines. The moment if I select both the zeros, your first D0 select line will be enabled. You can see there is the arrow mark. If I make 0 1, it goes to 1. If I make 1 0, it goes to the second. If I make both 1, it goes to the D3. So if I make both 1 1, if I make D3 is 1, your output will be 1. Your D3 will be 0, output. That means your D3 input is appearing at the output side. Now if you change any of the other inputs, is not going to affect your output because only D3 input is connected to the output side. If I make all the zeros, like both the zeros as select line, my D0 bit is connected to the output side. That means if I make D0 is 1, it's going to appear at the output side. Whatever I do at the D0, the same thing will be appear at the output side. Similarly, if I make 0 1, here D1 bit will be appear at the output side. So this is how your 4x1 multiplexer select out of these 4 inputs. One input will be selected based on the select input lines, and that will be transferred to the output side. Similarly, if you take the 18:1 multiplexer, this 18:1 multiplexer, where you can clearly see, if I make all the 3 zeros, you can see your I0 or D0 is enabled. If I make all ones, your 7th line will be enabled. If I make 0 1 1, your 3rd line will be enabled. The 3rd data line will be enabled. If I make 0 1 1, that means 3rd data line is enabled. That means your D3 is enabled. If I make changes, the same changes will be reflected at the output side. So that means the D3 output is multiplexed through this multiplex circuit and went to the output side. If I make all ones, my 7th bit is enabled. So that means if I make whatever the changes at D7, the same thing will appear at the output side. So if you change any other bits other than D7, it's not going to affect your output. Only D7 input change will affect the output, because you are enabled the D7 line by using your select line. This is how your 18:1 multiplexer will be selecting out of 8 data inputs, 1 data input to the output side.